Okay, in today's topic, we are going to look at areas and volumes of similar shape, and the learning objective is to solve problems involving the area and volume of similar shape, and this is our keyword. But before we embark on this, students should be familiar with finding squares, cube, square root, and cube root of numbers on their calculator. They should also be confident in solving linear equation. We have done this in our previous lesson. Okay, now we have to note this, that two solid shapes are similar if corresponding lengths are in the same ratio and corresponding angles are equal. We did this in our last time we were talking about similar shape. Okay, now if two shapes are similar and the linear scale factor is k. If the linear scale factor is k for a linear, then then the area scale factor will be k squared. We did this last time. And the volume scale factor will be k cube. Okay, I explained this last time. Okay, therefore the relationship between similar shapes can be expressed as the length ratio is x ratio y. The area ratio is x squared ratio y squared, and the volume is s cube ratio y cube. Please note these three. We are going to be using these three in a frequent solving of this question. Okay, now look at this. Now it says a solid has a base ratio of 5 cm and height of 20 cm and a capacity of 500 cm cube. Capacity means volume. A similar solid has a base ratio of 2 cm. What is the length ratio? Now for us to find the length ratio is given by the ratio of the two radii. The two radii 5 and 2. So the length ratio will be 5:2. This will be the length ratio. Okay, now 5:2. Now if you're asked to find the volume ratio will simply gives us the cube root of the length ratio. That gives us 5 cube is to 2 cube, which is equal to 5 times 5 times 5 into 3 places is 125 ratio 2 times 2 times 2 into 3 places is 8. Okay, so this is the volume ratio. Now the third question says, what is the volume of the small solid? Now the volume of the small solid, we have the volume of the big solid to be 500. Now if I said let this volume of the small solid to be small v, that means that we will say that volume of the small solid divided by the volume of the big solid or the large solid. Okay, and this will be equal to the volume of the small solid is small v over the volume of the large solid is 500, and that must be equal to the volume ratio, and volume ratio is the small solid is 8 and the big solid is 125. Okay, so we can cross multiply to find our v. So that gives us if we cross multiply, we have that small v will gives us 8 times 500, then whatever you have divided by 125. So that gives us let's check that. We have that 8 times 500 will give us what? 4,000. So 4,000 divided by 125. That gives us 32. So the small volume will give us 32 cm cube. So that's how we solve that. Okay, now let's look at this. This case, it says that a toy brick has a surface area of 14 cm squared. What could be the surface area of a similar toy brick with length that are twice the corresponding length of the first brick, 3 times the corresponding length of the small brick? Okay, that means that the first brick we have should be the small one, which gives us that surface area is 14 cm squared. Then the other one, which is twice of the corresponding length. So if this length of this is small l, that means that the length of this will be 2 small l, because it's twice the corresponding length. Now we are looking for what? The surface area. We're looking for the surface area of this. Before we can find the surface area of this, first of all, we need to find the length scale factor. Now for us to find the length scale factor, we have the length of the big one, which is 2l, divided by the length of the small one, which is small l. So if I divide this, I have that to be what? 2. See that? That gives us 2. So we can now have that the area, since the length gives us 2, therefore the area scale factor will give us what? 2 squared. We did this in our last lesson. So that gives us what? 4. The volume, or the area of the other one, the first one, will now be what? This 14 times what? 4. See that? And that gives us what? 14 times 4 gives us 56 cm squared. Now if it is 3 times the corresponding length of the first brick, 3 times will now be, if this is L, this one will be 3L. That means 3 times. This will now be 3L. That means that the length scale factor will give us 3L divided by L, which is what? 3. And the area scale factor will be 3 squared. The cube scale factor will be 3 cube. I hope you know that. Now, since we are looking for the area, that gives us 3 squared, which is what? 9. And now the area, the surface area, will now be what? 14 times 9. So 14 times 9 will be what? 14 times 9. That gives us 126. So that gives us what? 126 cm squared. Okay. Now look at this shape. It says below are 2 similar cylinders. Cylinder A has a volume of 26 cm cube. This one has volume of 26 cm cube. Work out the volume of cylinder B. If you're asked to work out the volume of cylinder B, first of all, I'll look for the length scale factor. The length scale factor is at the length of the big one divided by length of the small one, which is 6 divided by small one, and that gives us 2. So the volume scale factor will be 2 raised to power 3, because we are talking about volume. If it is area, it will be 2 raised to power 2. So the volume is 2 raised to power 3, which is what? 8. Okay. Therefore, the volume of B will be the volume of A multiplied by the volume scale factor, which is 26 multiplied by 8, and 26 multiplied by 8 is what? 208. So this gives us 208 cm cube. In the other hand, says work out the surface area of A. Surface area of A. If the surface area of B is 224. For us to work out the surface area of A, first of all, we know that the length scale factor is 2. We obtain to be 2. Therefore, the area scale factor will be 2 squared. And 2 squared is 4. Now, we are asked to find the surface area of A, the small one, if the big one is this. So for us to find the small one, we need to divide. If we want to find the big one, we need to multiply. So not the two of them. So to find the surface area of the small cylinder, if the big cylinder is this, therefore surface area of the small cylinder A will now be what? 224 divided by what? 4. So 224 divided by 4 will give us what? 56. So 56 cm squared is the surface area of what? A. So that's how we solve the problem. So if you have any question, please do let me know. Thank you for listening.